Hi scholars, in this particular video we are going to be cracking three tricky but commonly asked questions in exam. At the end of this video, every student should be able to understand organic reaction a bit in answering questions straight down to test of proteins. Right? Now we are going to go straight and dive into these questions and crack them sequentially. Now, the first question says, which of the following reagents does not follow Markovnikov rule in addition reaction to an alkene? And the options are ACl, BH3, which is also called borane, you have a sulfuric acid, and you have also chlorate 1 acid. But before we dive into this question, we need to understand, first of all, what is Markovnikov rule and what does it state? Markovnikov rule simply states that during the addition of a protic acid, and this protic acid, we signify it by this symbol, right? That during the addition of a protic acid to an alkene, and this alkene are majorly unsymmetric what now alkene, right? What happened? The hydrogen atom or the hydrogen ion is added to the carbon that contain more hydrogen already, while the other part is added to the carbon with fewer hydrogen atom. And this can be illustrated briefly like this. If I'm having propene, for example, my major interest here is between the double bond across these two carbon, right? This is one part, this is the other part. Am I correct? Please take note. Now, when a protic acid is added to an alkene, the hydrogen part of that protic acid is added to the carbon that has more hydrogen, because this one has two hydrogen, this one has one hydrogen. Take note, the double bond between these two these two carbon, not this one. A lot of students get it all twisted. Not this one, but this two carbon that is being separated by a double bond. Now, what are the examples of protic acid that can be used? We have HCl, right? We also have HBr and so many other examples. But in this case here, HCl can be broken down into two. So if I'm having HCl, I can be having hydrogen ion and chloride ion. If I'm having sulfuric acid, I can be having H plus and HSO4 minus. If I'm having also chlorate 1 acid, which is same as if I'm having H, I can have OCl minus. Is that so? The only odd one now is borane, BH3. Borane simply follows the anti-Markovnikov rule, which takes part in the hydroboration oxidation of the alkene, right? So the correct answer here is BH3, which is a borane. It follows the anti-Markovnikov rule. Do not fail to understand the difference between the two. In my next video, we will talk about the salient differences or the salient points between the Markovnikov rule and the anti-Markovnikov rule. Always do well to subscribe if you are watching me for the first time, so when my video is uploaded, you can always have first-hand information about the latest update in organic chemistry and other areas of chemistry. So we move to the next question, number 2, which says, when a protein is treated with sodium hydroxide and copper 2 sulfate, a violet color is usually observed. This describes what? Is it Miller's test, nitric acid test, Biuret test, or the Felin's test? Now, this is simply a test for protein. Now, basically, there are some tests for proteins, right? But the one that best describe this one here with the shortcut, which is sodium hydroxide and copper 2 sulfate to give me violet color, is simply what? Is simply a Biuret test. A Biuret test. Now, let us talk briefly on each of these tests that is outlined on the board. Miller's test. Miller's test is one of a test for protein, but basically it detects phenolic what? Amino acid, meaning amino acid that contains what we call that contain a benzene ring and also an hydroxy group. A very good example is tyrosine. And how do we confirm that? The formation of a red precipitate is simply a confirmatory test or a positive test for Miller's test. Then we then talk about the nitric acid test, which is also called the xanthoproteic test. Now, what is it all about? Simple. This simply talk about or test basically, listen, it tests basically or it detects basically aromatic what now? Aromatic amino acids. And what and how is this test confirmed? It is simply red, and when it reacts with an alkali, it turns what? Yellow. This is simply a test or the confirmatory test for what now? For nitric acid test. Then we then move to Biuret test. Biuret test is simply a test or a chemical test to detect for the peptide bond in a protein. Remember, a peptide bond is a bond formed when two amino acids, right, undergoes a condensation reaction, right, and a peptide bond is formed. Is that understood? Yes. And what are the reagents? The reagents are simply sodium hydroxide and copper 2 sulfate. The copper 2 sulfate is simply used to react with the peptide bond, meaning if there's a peptide bond in that unknown sample, right, copper 2 sulfate will react with it, right? And the confirmatory test is simply violet or purple color, which is a test that is positive for it. D cannot be the answer because this is simply a test for sugars, right? Precisely reducing what? Sugar. And a confirmatory test for Felin's test is a brick red precipitate. Is that understood now? You can see how very easy it is. So it is not to just say that the answer is Biuret, right? But to understand why others aren't the answer, right? So now you know that for a Biuret test, when you see in your exam sodium hydroxide plus copper 2 sulfate solution to give you a violet or a purple color, it simply tells you that what? That the test is what now? Is Biuret test. And lastly, we move to what we call number 3 question now, which is which of these reagents can be used to produce alkyne from alkyne? You are given A, sodium in liquid ammonia, palladium in ammonia, Lindlar's catalyst, and lastly, platinum in ammonia. Now, this is a very unique question. Now, remember, you are to produce alkyne from alkyne. This is simply a partial reduction, because a complete reduction, right? A complete reduction of alkene should give me alkane, but rather they are telling you which one will give me an alkane. First of all, we should understand some certain things here. If I'm to use sodium in liquid ammonia, right, I will have an alkene, but that alkene is a trans alkene, meaning to prepare a trans alkene, you use sodium in ammonia. Am I correct now? Yes, you cannot make use of palladium with ammonia, right? This will give me, normally it will give me straightway alkanes. So the correct answer here is Lindlar catalyst. Why? Lindlar catalyst is simply palladium, right? Palladium in the presence of barium sulfate that is being poisoned with sulfur. This will give me a cis-alkene, meaning for trans-alkene, we use sodium in liquid ammonia, while for cis-alkene or just alkenes, you will use what we call Lindlar catalyst. Palladium with barium sulfate poisoned with sulfur. And this actually marks the end of this first part of this series. Do well to like, share, and for students who are preparing for 100 level exams in Nigerian University, and also students preparing for A level exams in any other universities of the world, you can, of course, share it to your friends, because this is getting more interesting. I remain my humble self, Adrenaline, the Bazooka Prophet, BSc, MSc, PhD. One love, and God bless you.